Welcome to Unit 4, Conic Sections. We're going to break this foldable into several different parts. You can watch as many or as few of those parts as you wish at a time. Just make sure that you're keeping current in your with the calendar so you don't fall behind on any of the notes. Conic sections are formed by the intersection of double right cones and a plane. On the next page, I'm going to describe some of the lines of symmetry of each one of them. You may want to use these four already drawn conic sections for you to identify those. We'll talk more about how the double right cone is intersected by the plane and how it's created a little bit more in detail. So, a circle has infinitely many lines of symmetry. An ellipse has only two. They run along the major and the minor axis. The parabola only has one. It goes through the vertex and the focus. And the hyperbola has two. That is one that runs through along the transverse and the other along the conjugate axis. Please use the pause button as much as you need for this. I know that there'll be a lot of writing and I'm going to move through each slide relatively quickly, so make sure that you have all the information you need before moving on. Alright, we'll begin with our first conic section, which is the circle. Please make sure that you fill in all of the missing details, including all of these notes that are underneath each one of these rectangles. This is the standard form of a circle. Alright, each parts of your circle include these 6 vocabulary terms. So we'll go ahead and identify each one of them. Your center is located here. The radius is the distance from the center to the edge of the circle. The diameter is the chord that goes through the center. A chord is just a line segment that goes from one end to the other. The tangent will intersect the circle at exactly one point, and the secant is a line that goes through at 2 points. Identifying a circle based on all of its parts. Your H and K is your center. Notice that the values are subtracted for positive values of the center. The radius is R, so pay close attention that sometimes that will be squared. When you're graphing a circle, make sure that you write the equation in its standard form in order to identify the center and radius. Plot the center, and that should be an E, not us. It should be use the radius to find all points R from the center. Use the radius. Alright, let's go ahead and take a look at a couple of examples here so that we can correctly identify circles. So the center that we're going to start with is 4, 3. The radius is going to be 2. Therefore, the equation is going to be x minus 4. I gotta start that one again. X minus 4 squared plus y minus 3 squared equals 2 squared, which is 4. Alright, so we'll begin by setting our center at 4, 3, and then we'll go ahead and create our circle. Radius about right there. Right, domain is going to be from the left to the right, from 2 to 6, and the range is going to be from the bottom to the top, which is 1 to 5. Circles are the easiest of the 4 conic sections to work from, so we're not going to spend a lot of time working on them. If you have a circle whose center is at the origin, then you simply leave out h and k, and you get x squared plus y squared equals 5 squared, which is 25. Your domain from left to right is negative 5 to positive 5. And your range from bottom to top is negative 5 to positive 5. We'll finish off with one last example. Please turn to the back of your conic sections foldable, and please find this page, which includes the examples. After the completion of each set of notes, we will complete each one of these examples, so by the end you will have all of the examples you need. Okay, a circle is centered at negative 3, 5 and has a circumference of 8 pi. We will use the circumference to find our radius. That will be our first part. Circumference equals 2 pi times the radius, so 8 pi equals 2 pi r. Dividing out your 2 pi removes pi from the equation, and 4 equals radius. Now that we've done that, we can simply write our equation in standard form, which is x plus 3 squared minus y minus 5 squared equals 4 squared, which is 16. So I'm going to go over 3, up 1, 2, 3, 4, 5, oh, it's ugly, and draw our circle with a radius of 4. And there it is.